Hi everyone, my name is Milad and today I'll be doing a system design practice exercise. I'm doing these to help improve my skill set. However, I hope in that process you guys learn something as well. Remember, there are many ways to solve a system design question, so make sure you check out how other people solve this very exact same question. If you do enjoy the video, please consider liking this video, leaving a comment below, and if possible, subscribing. With that said, let's dive right into our system design question. Today, I'll be designing a global inventory tracking service, and I'll try to satisfy the following requirements. Create an inventory tracking system for global scale. Track a single product type, green bananas, from one brand. Manage inventory across 3 separate warehouses. Differentiate bananas owned by the company and those by third-party sellers. Show banana stock levels at different locations. They are kept on pallets with varying quantities. Monitor bananas in various states, pallet, in transit, and ordered with ETA. Scale the system to support up to 100 million SKUs in the future. All right, well, one of the things I can tell you from experience, whenever you are working with diverse set of products, you will always want a flexible and elastic data structure. And that is because different products will have different properties. And while you can achieve this in a structured database like SQL, a NoSQL database is ideal for this scenario. Alright, so let's take a look at one of the things I want to identify right away is to know what entities I'm working with. So we need tracking, and we need a product, manage inventory. We have to keep track of inventory. We want to, we have warehouses. These could be locations. Let's see, we have anything else I need to take into account? We have product, location, we have state. And okay, that's a great start for us to figure out. Oh, we also need brand association to products, inventory across multiple warehouses. All right. And then we have companies, so we will have different companies working. So brand, warehouse, inventory tracking. Let's just do tracker here. Location. So delivery could be from warehouse to warehouse or warehouse to store. So let's just say a store here. I mean, it could go different places, but for the sake of this exercise, I'm just going to keep it to that. All right. So this is going to be a key point here is we definitely want to have multiple load balancers here, and we are going to be working with 100 million SKUs. That means we're going to have really high volume. So we'll need to be scalable and high throughput. So let's jump right into a database schema. That's where I like to start off with. It allows me to get an understanding of the type of functions I want to work with. So once again, I'm going to go with NoSQL database. So we'll be working with collections and documents. If you translate that into SQL terms, that would be tables and rows. So we'll have our first collection, which will be a product, and I'll only identify the essentials. So we have product, brand ID, we have company ID, and we have, let's say, status ID, we have location ID, and let's see what else we need. Anything else? Okay, so that is there. And obviously, remember, this is an open-ended design, we can have any other metadata that we deem appropriate, and different metadata for different products, because we don't have structured data here. And then we have locations. Let's do location. We have name, address. Let's do city, state, zip code. And because this is unstructured, if you have locations in another country, you'll have a country ID, and that'll let you know if what kind of data to expect. So okay, let's just do that. Well, another thing we want here is location type. And what location type will tell us is if this is, for example, we can use these as warehouses, but later on we can have stores and anything else we want. Okay, so then what else we want to do? We have brand. What's the name? Obviously, all these things should have ID, location, ID, product ID, brand ID, and I'll keep the data to a minimal, just so we can make progress here. And once again, if I do this, that means any additional metadata you want. Let's see. Company brand, we need now company. And we have name, company ID, and any other information we want. So let's see here. Over here, I'll add an additional thing so we know what type of product we're dealing with. Product type ID. And what you can do is extract some of this information, because multiple products can be owned by different brands and different companies, but for the sake of simplicity, we're going to keep it like this. But you can normalize that even more if you wish, if you would like to. So now let's see, tracker, product inventory, warehouse. We've taken care of this. Let's get rid of that. We've got taken care of this stuff. Inventory, we got rid of, and tracker and inventory. All right, so now what we want is product location. We'll do location ID. We'll do status ID. We'll do quantity. And we'll do potentially pallet ID, because we're dealing with pallets, what pallet it's on. So that means we're going to need pallet ID here. Oh, sorry, pallet ID. Any other information you might want, I don't know, weight, for example, etc., etc. Over here, location, we have pallet ID, we have quantity. What we want is, let's say, arrival date stamp, exit date stamp, and another thing we want, product location tracker. This could be, let's see, here we want, actually let's let's just get rid of this. Let's just say from location ID. This lets us know this will let us know where it came from, and this will allow us to, yeah, this will let us know where it came from. Ah, geez. What we want is arrival ETA date stamp. That'll tell us when we think the product will arrive here and when it actually arrives. Product location update. Location ID. Oh, critical data missing here. Product ID. And we can have the long lat date stamp. This will let us know exactly that as the product is traveling, we can have this. We can have a service where the GPS is sending information to our backend server. Okay, that takes care of these two as well. Alright, so that is our database schema. Once again, this is the very basic to get us going, and obviously there's always room to add more, you know. And let's take a look at our APIs real quick. So we will have, let's see, product, a post product. And this will, for adding products, we will have get product, and we will have product ID. Let's just do the ID would come here, and that will give us our product information. Delete, same thing, product ID to delete it, and other generic ones as well if you want to update it. Update product with the data that you want to send to it. All right. Next, we want to do post warehouse. If you want to add a warehouse, update. Actually, warehouse product. If we want to update a product, put actually no, that doesn't make sense. Let me get rid of that. Oops. So this would just be warehouse. If you want to update the warehouse information, get warehouse details. Oh, jeez. Get warehouse inventory, and then get warehouse inventory product ID. Let's do product ID if we want to know how many products there are. Next, we want to manage our inventory. Post inventory with I mean, this could be multiple products that you're updating. Delete inventory. Once again, this could be adjusting the inventory in any capacity you want. It's a business decision whether you do one product at a time or multiple products. It doesn't make to do. It might make sense depending how granular you want to be and how thorough and how many safeguards you want to put in place. Inventory update. I mean, if you want to be a little bit more specific, you can have these product specific, for example, but that's just an option. And then obviously get inventory. This will get all of you, and if you all of your inventory, and if you want to filter it, you can do, for example, company get. You can do product get. Let's do brand and so forth. That's one of the many options you have. Next, we want to track post. Let's do tracking. Post tracking GPS location, and then once again you can do this a bulk upload, or if you want to be specific, product and then product ID, or post tracking GPS pallet with pallet ID. And then you can get, you obviously want to update here, tracking, and you definitely want a get. All right, tracking. And again, you have the option of, let's say, adding additional parameters. Let's just say a palette, for example, with an ID and so forth. All right. And then the other ones that aren't really important, like company, brand, those you can just take for granted. All right, so let's now jump into our infrastructure and what that looks like. So global, whenever you see global scale, you know you're going to need a global load balancer. The global load balancer will direct the traffic from your users or from the request to the most appropriate region. And you do that for many reasons. The most common reason is lowest latency, localized data, and sometimes it could be for more serious things like, you know, different countries have different regulations, so to adhere to certain laws. It also allows you to implement fault tolerance. If one region goes down, another one is able to take over the request. Then we have a regional load balancer. And a regional load balancer will then direct your request to the most appropriate data center. Now, every time you add an additional layer, you allow for increased fault tolerance. You improve your fault tolerance. You improve latency by making sure that the request is directed to the most appropriate data center, and you're also distributing load effectively. But the trade-off is increased complexity, increased overhead, and potential issues if you don't configure it right. If you're talking about the global load balancer, you got to take into account, when if there are any changes where IPs change, it takes a while for that information to propagate across the internet, and you can be down for as long as 30 minutes. So once we hit our we hit our data center, the request is passed through the API gateway, and this is basically the entry point into your system that allows the system to interact with the clients. Now let's take care of the product API request first. So we'll have a product service here, and the product service will be responsible for anything related to products. So if we take a post, what happens is we pass the product information to the product service, and it's really important that we make sure that we're able to handle the volume of information coming in. Now, one of the things that the requirement stated was the system should be able to scale up to handling 100 million SKUs in the future. So this will mean that there will be a large demand on this particular type of service. Now, how many products are added and removed? I think that'll be a much lower volume. It'll be very read heavy versus write heavy. So I'm not too concerned about handling the writes. If we wanted to, we could use a messaging queue, but whenever you introduce a messaging queue, although you have the assurance that your data will not be lost, you do impose eventual consistency. So that's one of the trade-offs you have to think about. And in this case, I don't think it would hurt, but I don't think it would help either. So here we would have our NoSQL database, and we will have our product information here. So we will write this service will then write that information to a NoSQL database. Now, update will go through the same process. Now, when we want to get that information, we don't want to hit our NoSQL database. What we want to do is we want to hit a service that's much faster in retrieving that data, and so we're going to utilize cache. Caching is the process of saving data, but unlike a database that saves it on hard drive, a caching service saves your data on memory. What that means is it's a lot more expensive, and you can have issues where you have data that's not synced or out of date. So we have we'll utilize Redis as a very common caching service. While there is overhead and complexity and cost, what you get in return is really fast response time. So we will have over here product information in our cache. So what's going to happen is when we get a GET request, the product service will look in the cache. It will try to find that product information there, and if it can't, it will send that information back. Next, we want to do our warehouse. So we will have a warehouse service. And this will be really low volume here and really low read and write volume. So when we're adding a warehouse, we'll save it into our database, and when we want to get information, we will hit our cache first, and then we'll hit our database. So in here we will also have warehouse. And so let's add that here as well. All right. So post will go directly to the SQL. Then we'll update the caching server, our cache with the latest data. If there's an update, we update the cache first, and then we'll write through to update our database as well. When we do a get, we're going to look into our cache to see whether that information exists, and if it doesn't, we'll then look in our database. And all right, next we want to handle inventory. So we will now create an inventory service. And our inventory service will manage everything related to inventory. So when we update our inventory, we first check that the product, we communicate with the product service and say, hey, do these products exist? And if they do, we will then confirm that, and we will update the cache with the quantities of these products. Additionally, we will also update our database as well. Now, this will allow us to, so if we look at this, if we're doing a put, once again, we communicate with the product service, say, hey, is this a valid product? Just to verify all the products. And then if everything looks good, we update the inventory, the quantity of each product. We'll update the cache and the database as well. Next, we want to go to our tracking service. So we'll have different types of updates. The first thing we want to do is when we want to initiate a new location, we will tracking service. So what will happen is when we're updating, when we say, hey, this product is in service, we first make sure we will communicate with the product service. If everything looks good, we then update the cache will update the database to say, hey, look, we have a new entry here. And for this, we will, okay, we will say, all right, this location is, this product is in motion, so we create an entry for the product location. And what we want to do is actually thinking about this. Let me just redo this for 1 second. We'll put this into a messaging queue here. Now, messaging queue is a way of passing on information that can be handled by processed by one or more services at the other end in whatever capacity you want. And this will be traffic topic. So one of the messaging services out there is called Kafka, and that allows you to send a message to the service, and then there are services subscribe to that service that are looking for messages, and as soon as they see that, they process that information. So it provides an ability to manipulate, utilize data by many services without having to hit the database. And Kafka is highly reliable, so you know that you'll never lose the data that you put in there. So we know, let me add another thing here. I'm going to do a location service. The tracking service will validate that the locations are valid. The location service will communicate with the cache server. I'm trying to make this pretty, so bear with me for 1 second. It will communicate with the caching service as well as the database in case it doesn't find the information in the database. And once the tracking service has validated that the destination, the location ID is, actually let's just update this to, to location ID, and we can just change this to product location ID. It will validate that information, and then when it looks good, I'll write that to the topic. And then what we'll have here is ETA service. The ETA service will read the messages from the messaging queue. it'll look at where it's going, where it's coming from and where it's going, and then update the cache and the database with its ETA. So that we have an ETA system. All right. And then let's see here. Next, we want to update GPS. So now we're updating this, and this is going to be very high volume. So what I'm going to do is, although we have a tracking service, I want to just create a designated service here that does simply GPS updates. GPS update service. Now, there are two ways to approach this. One is you can use your NoSQL database for this specific thing. The next is to use a different database altogether, like a time series database, which would be great for this type of information because it's really high volume, and that really depends on the frequency you want to update the GPS location, how accurate you want it to be. And this will write to a Kafka topic here. And then what we do is if we come here and we will have a service called, let's just call it GPS update. Oh no, GPS over there. I'll just name this GPS service, and then this is update save service. And this is a job that'll read this data in bulk, and then update our database with the location service. I think in this case, you know what? I think it'd be a good idea to use a time series database like InfluxDB. Wait a minute, what's going on here? Now, InfluxDB is great for data, time series data, and this would be perfect. So we would have GPS data points here. And what we can do here is we could have a third party third-party service that we utilize, and then we can have some, data science service, GPS data science service that processes this data and then can spit out some information that the ETA service can utilize to determine. I mean, this would be a far more complex flow, but you get the general idea. Utilizing current or forecasted traffic along with our historical data, we can come up with a more accurate ETA for these products as they are in motion. So that is it. That is my take on this. Anytime, for example, adding InfluxDB, while it's great for time series and from data like the GPS data, we're adding additional costs, additional overhead, but that also gives us the ability to store these independently and process that information later on for analysis and data mining. And as always, double check anything you see and hear in my videos. There are people who have different takes on this. Take a look at them and see what they say and compare the two and come to your own conclusion. If you did enjoy this video, please consider subscribing. I would really appreciate that. And most importantly, I'd love to see some comments down there. I'd love to know what I did right or what I did wrong so that I can improve myself. Thank you so much. Have a wonderful day.